Hello, everybody. Welcome back for a new episode of the Midnight Session. This episode is going to be packed with a lot of information that just came out this morning. For those that are attending, just let me know if you can hear me well. You can see my screen. At the end, I'm going to enable the option to jump into the stage to discuss any questions you have. Also, if you want just to write, there is a chat option here on the right. And well, let's start. Regarding the ecosystem, we're going to talk about the Glacier Drop. The official site just came out this morning, and we're going to discuss all the details, all the constraints, and everything about Glacier Drop. So I want to share first this tweet of Midnight Foundation. They say, to our community, your patience, passion, and belief brought us here. The moment we've been all waiting for, it's now. Glacier Drop is officially live. Eligible wallets can now begin the claim process. We're gonna read through that process as well. Head to midnight.gd, that's the official site, for full instructions, questions, and updates. And they're gonna have a tweet space later today for my local time, which is Brazil. It's at 5 p.m. So this is the official site they share. Make sure that you guys are joining the official site, right? For sure, there's gonna be a lot of fake sites going around. So make sure you have this domain, claim.midnight.gd, and here you can see that everybody that wants to do the claim, they're gonna have to go through these 4 steps. First, they have to decide what is the origin address, then the destination address, accept the terms, and just sign and complete the claim. And as we mentioned before on previous sessions, we have 7 blockchains and 1 token available, the BAT token. Okay, so let's discuss some things about the Glacier Drop. So here they are making there is a blog from the Midnight GD team where they're explaining what points were taken in consideration for calculating the allocations of nights. So let's take a look at this. Following the network snapshot, June 11th, this post provides the resulting data for the Glacier Drop. It covers the final number of eligible wallets, the distribution percentages across all 8 ecosystems. So here is the recap of eligibility criteria. Eligible ecosystems. So what are the 7 networks and 1 token? Cardano, Bitcoin, Ethereum, Solana, XRP, Ledger, BNB chain, Avalanche, and the Brave token. Minimum balance, $100 for each address to be able to claim, and transaction addresses. Eligibility by chain. So now they made a summary of how many nights each address is going to receive for each of those addresses of those networks. For the case in Cardano, Edda, eligible addresses, more than 1 million addresses, and the allocation rate, it's going to be 0.34 nights per each Edda, which is a lot of nights for the Cardano community. Bitcoin, eligible addresses, 17,000, and for each BTC, people are going to receive 696 nights. And this goes for other blockchains. XRP, it's more than 2 million eligible addresses and 0.04 nights for each XRP. Ethereum, 7,000, 50 nights for each Ethereum. Solana, 3.4 millions, and for each Sol, 2.9 nights. BNB chain, 1 million, and for each 1 BNB, 12 nights. Avalanche, 227,000 addresses, and for each AVAX, people are going to receive 0.4 nights. And the BAT token, 24,000 for each BAT, 0.0025 nights. Something really nice about this chart, it's how many eligible addresses each network had, right? So Cardano, you see there's almost a little bit more of 1 million. But Bitcoin, you have 17 million. That's a lot of addresses. For other blockchains, it's pretty much close to 1 million as well. 2 millions, 7, 3, 1, and Avalanche is just 200, right? But Bitcoin, it's kind of astonishing, right? How many addresses were eligible? 17 million. Okay, what else? Here it's the total allocation for each network. So we can see here that in Cardano, it's 12 billion nights that are going to that ecosystem, representing 50% of the total allocation. In the case of BTC, it's 4.8 million that represents 20%. And then for the other blockchains, the way they did, it's they grab the remaining, which is 30%, since we have 50% for Cardano, 20% for BTC. The remaining 30% was divided based on the market cap of each blockchain. At the end, we have these percentages. XRP, it had 10.9%. Ethereum, 9%. Solana, 5%. BNB, 3%. Avalanche, 0.18% of the total allocation. And the BAT token, 0.013%. And then just preparing for the claim, which now it's live, right? People can jump in. So the thing that I want to discuss now is that people are gonna go through this process of the Glacier Drop. You're gonna have to select your addresses, your destination address, and then you're gonna have to sign. So each of those processes, you're gonna have to, at the end, implement 2 actions. One, it's connect to a wallet, and then sign a message. Each of those actions can be done in different ways. So this is what we're gonna go through, reading this blog and see what are the constraints, limitations, if there's any, still, and talk about it. And then we're gonna go through some tweets where we were discussing during this morning some constraints that I had while reading this blog, and they were solved. They are solved now. So, okay, let's start. First, they are saying here, what are the verified wallets and compatibility for each one of those? Since we are talking about pretty much 7 blockchains and 1 token, that's a lot of different type of wallets, addresses, hardware wallets, and different ways to actually prove that you are the owner of that address. So let's take a look of each one of those networks. For Edda, we have the following browser extensions that were tested. You have Lace, Yoroi, Typhon, Giro, Vesp, Eternal, Desktop. Hardware wallets, this is a huge topic. We're going to discuss this a little bit later. And they say here, post-launch, see section below. And the manual path, it's verified. You have a manual path. We're going to see that as well. For the case of Avax, they list the different wallets that have been tested. The hardware wallet support, it's NA. There's no hardware wallet support. You have to go through these light wallets. And the manual path, it's verified as well. In the case of BNB, this is a list of the light wallets that have been tested. The hardware wallets, they have Ledger and Trezor. This is 2 ledgers that are being supported and they have been tested. We're going to see then that there's another hardware wallet that has already been, not sure if it has already been tested by the team because it hasn't been listed here in the blog. Maybe they're going to update it later on, today or tomorrow. But we have received confirmation by the team that their hardware wallet is working perfectly, which is Keystone. We're gonna see a tweet later on. The manual path, it's verified. In the case of BTC, you have these light wallets available and tested. Hardware wallets, again, you have the Ledger and Trezor, and you see here that they say native, and we're gonna see why. Because in some cases, for example here, In BNB, they mentioned Ledger, Wallet Connect. And for Trezor, we have native. So native, it's you're actually gonna talk directly with the implementation of that wallet. And Wallet Connect, this is a protocol that actually connects with a ton of other wallets, and you can actually use your hardware wallet to connect by Wallet Connect. Okay, BTC, so you have this, Ledger, Trezor, manual path, it's verified. The BAT, you have these light wallets available. This is the hardware wallets. Again, you have Ledger and Trezor and manual path verified. And in the case of Ethereum, you have all these, MetaMask, which is the most common. Hardware wallets, again, Ledger, Trezor, and manual path verified. And in the case of Solana, you have this bunch of light wallets. Hardware wallets, you only have Ledger. You don't have the option of Trezor. XRP, again, you don't have any hardware wallets option. And light wallet, there is just one, which is the Saman. Not sure if I'm pronouncing it correctly. Saman Mobile. So at the end, this is the list of all the light wallets verified and tested. Right? In the case of Cardano, we have Eternal, Lace, then we have Yoroi, we have Typhon, Giro, Vesp, and that's it. And the hardware wallets, we're gonna see later on what's going on with the Ledger and Trezor when it comes to message signing. So here they explain the difference between native connectivity and wallet connect. So a wallet can connect to a portal in two ways, either via native connection or via wallet connect. So native connectivity means that the development team has implemented support specifically for that wallet network combination. For Cardano-based claims, connection with a portal is only supported via native connection. See Cardano wallets below. We're going to see that in a moment. Native connectivity is also supported for some combinations of hardware wallets and tokens. And the wallet connect, it's an addition to native connectivity. The Night Claim portal employs the industry standard wallet connect, also known as REON protocol, as a connector with all non-Cardano networks, thus potentially extending compatibility to dozens of other wallets. Okay, so now we have some review about Cardano wallets, specifically for the Glacier Drop. So they mentioned here that for Cardano-based claims, only native connectivity following the ZIP30 standard is supported. The wallet connect, it's not, right? This means that the portal is only compatible with the Cardano wallets listed on the table above, right? This list that we just saw. This means that the portal is only compatible with the Cardano wallets listed on the table below. Wallets not on the list are currently unable to connect with the portal. Support for more Cardano wallets may be added for the distribution begins, right? So they are already testing with more wallets, and as they finish testing, they're gonna add them on this list here. If your Cardano wallet is not listed, you can always follow the manual path. We're gonna see there's some people already implemented this manual path. We're gonna take a look at that in a moment. Or import the accounts containing your eligible addresses into one of the verified wallets. What happens with the unverified wallets? For non-Cardano based claims, if your favorite wallet is not listed as verified, it was not tested and verified by the development team. Sorry. However, connectivity between the portal and unverified wallets may still be supported. Okay, this is a huge topic, hardware wallets. So they mention here that the Trezor wallet connects natively with these different blockchains. Node wallet connect connectivity between Trezor and the portal. And for Trezor, it's not currently compatible for making Avalanche, Solana, XRP, and Cardano-based claims. And in the case of Ledger, the same thing. They mentioned here that they connect natively to these blockchains and is not supported for these other blockchains and Cardano-based claims. So what we can see here is that Cardano is not supported neither by Trezor, Otherwise, I don't know why he did that. Let me see here. The Ada blockchain for the signing process is not supported by Trezor, and it's not supported by Ledger. So what happens then with all Ada holders that are secured by those hardware wallets? How are they going to sign the transaction? How they going to send the message? So we're going to see that in a minute. Let's continue reading here. Hardware wallet support for Ada based chains. Not sure why it's keep doing that. So the development team is working on the Glacier Drop. Identified that neither one of the two hardware wallets tested currently supports the specific message signing, something that I just mentioned. A standard required to verify ownership of the Cardano Ada network. As a result, hardware wallet support for Ada claims will not be available at the time of launch. So, okay, they mentioned that they are working on something. To avoid delaying, they have already started this claiming process. So regarding this topic, I was like, okay, we're gonna have to wait for the Midnight team to make an available option for people that are using hardware wallets. So I make this tweet today. Let me see if I find the tweet here. I'm gonna. So I make this tweet. I think I didn't open it. Let me open here my tweet. So I make this tweet today in the morning here, mentioning a topic that will be covered in today's midnight session. Curious whether Keystone supports Cardano message signing and if it's been tested on the Glacier Drop. So just mentioned, they on the blog that we are taking a look, they mentioned that Ledger and what is the other one? They mentioned the Ledger and the other hard wallet, it's Trezor, is not supported. But what about Keystone? So I made this tweet asking Keystone if they have already tested their wallet and if it's working. And amazingly, after pretty much 1 hour, the community was really eager to test the application, and some of them hold the Keystone hardware wallet, and they just made this confirmation. Attention Cardano family. Have you claimed your Midnight token using your Keystone 3 project? So there is this community member that they made this tweet saying, just claim my Night token with Eternal and Keystone wallet. And guess what? It worked at the first try. So here they have completed the process and it works fine. So now the Cardano community, they already have an option to claim using hardware wallets. If you have a Keystone 3, you're going to be able to claim. If you don't have the Keystone hardware wallet and you just have Ledger and Trezor, you're going to have to wait for the Midnight team to make something available, right? For those having those hardware wallets. But at least we have one option. If you have a spare Keystone that you're not using, you can actually import, right, your seed phrase and actually do the message signing using that hardware wallet. Excellent. So now they mention all things about addresses, right? We're going to focus on this about Cardano because there is a bunch of different addresses depending on the network, right? But in the case of Cardano, they made a really nice summary here that they mentioned that in Cardano, all addresses, it's pretty much divided by two, where the first part is mandatory and the second part is optional. The first part is the payment part that they mentioned here. It's the base address is the payment part, and the second part is the delegation part. Each of those can be a state key hash for the delegation part or a payment key hash, or it could be a script, which is a smart contract. So at the end, what is the summary? If you have a key hash either for the payment or the delegation, you're going to be able to claim. If your address it's only created using scripts, then you're not gonna be able to claim using that address. But if, for example, you have a address that is a smart contract, but your delegation part it's a sticky hash, you're gonna be able to claim the nights allocated for that smart contract. And then they mentioned here other addresses. For example, for the Bitcoin, the legacy ones are supported, but for example here they mentioned that one of the addresses of Bitcoin it's the taproot, and this one is not supported, which ends with BCP1P, right? If your address starts with BC1 KQ, then it's supported, but only this taproot is not supported. The same thing for Ethereum BNB Avalanche, where smart contracts they cannot sign messages. You need to have one of these. They mentioned EOA addresses, which is externally owned account addresses. Smart contracts are not supported. Excellent. So that's regarding the Glacier Drop. So, well, it's going to be really nice to see all the community going through this process and claiming their tokens. Now, we're going to go through the Dev Diaries and the codes. We're going to be talking about one of the starter templates that Mesh we just delivered for developers to start creating their contracts and their applications really fast. This is something that we've been going through the last midnight sessions. We just created the final first version template. So we want to go through them. In the later episodes of the midnight sessions, we're going to go in detail of each part of this structure. But now I just wanted to give a big overview of the structure and talk about something new that came out on the tooling regarding Compact that was described in this diary. So let's take a look. For this diary, they mention introducing the Compact developer tools. We are proud to announce the launch of the Compact developer tools. Today, we are launching Compact, a command line tool that is used for installing the Compact toolchain, the compiler, keeping it up to date and invoking the toolchain tools themselves. They made a really, really nice job here. I mean, for those that have already gone through the process on how to install the compiler, the Compact compiler, it involved a lot of steps for it to work correctly. And the upgrading the version, it was already a pain because you have to delete, you have to download, and have to go through all the process. Now with this tool, it's really simple and quick. We're gonna take a look. The developer tools are now the official supported way to install and update the toolchain and to invoke other Compact tooling such as the Compact compiler. So right now they just released the first version, but they plan for having this tool to involve all different future toolings that they're going to introduce into the ecosystem. To avoid confusion, we will make a careful distinction between the Compact toolchain and the Compact developer tools. So let's see here. Now, for installing the toolchain, we have this method, right? You have to download the binary, and then you're gonna have access to that command within the CLI to perform different actions, methods. For example, one of those methods, it's called Compact update. When you run that, you're gonna see what is the latest Compact toolchain that you have installed, and if case you don't have any, it's gonna go through the process automatically. What is another command? Compact check. So this check, it's like confirming that you have Compact installed on your computer and what is the version that you have. For example, in this case, they are running this Compact check and they are having the result here as latest version available 0.25. There's a note here. You will not actually see this output until there's a new version available. Instead, you will see that you're on the latest version. Switching toolchain versions. So there is this Compact list that is going to list all the compact toolchains available. The latest one, we have the 0.24, but for example, you have the 23, 22, in case you have some compact code that it's only compatible with these versions, right? But if you are creating a new contract from scratch, you have to use the latest version, of course, to have the latest features. Then, for example, you have compact list installed. This is going to list all the installed compacts, right? Here, they mention what are the available compact toolchains. Here are what are the compact toolchains that you have already installed in your computer. So here you say install versions 0.24. The update subcommand can be used with a specific version to switch to that version. This command is really nice. For example, compact update 23, right? So you can just, for example, if you have version 24 and you just want to downgrade to 23, you just update to the version that you want. So in that way, you just switch between versions really quickly and easily. What else? Invoking the compiler. So now to run the compiler, you just have to run compact, compile, and just giving, it's pretty much the same structure that we had before, just changing the method. And this one, it's something that I really like. So you can update, you can change versions using this compact update, but within your scripts in your code, you can actually choose something running this compact compile. So you can run compact compile and then choose the version that you want to run your compiler and just say what is the contract file and what is the output directory. So in that way, you don't need to create a documentation saying for the user to actually update to a specific version. You can just make sure that in your scripts is this command, so automatically updates to the version that you want. Then there is some built-in help that is going to list all these methods. So for example, you have compact and you have this method compile. If you don't remember what are the methods available, how it's structured, you can use this flag to actually list all the different methods that you have available. For example, compact update help. And then you have the versions, compact versions, compact update versions. This is another flag as help. You have this version. The developer tool are separately versioned from the tool chain. This is something that was really confusing at the beginning for some folks that couldn't understand what is the difference between the tool chain and the developer tools. And what happened, we want to have in the future different tool chains. And the developer tool, it's a way to install those tool chains. But not necessarily you have to update the developer tool whenever a new version of a tool chain updates. Otherwise, it would be really tricky, right? You would have to be upgrading all the time your developer tools. So this separation is nice to have, because in that way, whenever something updates here, you can still use the developer tool without having to keep upgrading all the time. And something nice they mentioned is that developer tool it's capable of upgrading itself. So yeah, that's a really nice developer experience. So they mentioned here, right? Keeping the developer tools up to date. Once they are installed, the developer tools are capable of keeping themselves up to date. Really nice. You can check for updates with compact self-check. We have not provided a way to go back, right? Not sure why anybody would like to downgrade the developer tool, because it's not like the tool chain that we just mentioned, that we have, for example, these different versions that depending on the compact that you have, you might want to use a specific version. The way it's going to work this, since they're separated, this developer tool, independent of the version that you have, it's going to be able to install for example, version 0.23, right? Without having to downgrade. Okay. And that's it. We're going to test that in code for this last template that we just released. We're using this compact tooling, new compact tooling. So we're gonna take a look at that in practice as well. So now we're going to go through all this process and we're going to understand how to use this template for new contracts that you want to implement. So I made this tweet saying, if you're building on Midnight, this is the tool you've been waiting for. The starter template from Mesh gives you everything you need to start fast without worrying about boilerplate or setup. Built for developers who want to focus on shipping scalable and composable dApps from day one. Really happy with the results. So this is pretty much like a framework that gives you different options to integrate other smart contracts. What you have in this template, we have a wallet widget integrated that you can connect to the Lace wallet. There is a framework established, so we can have composable contracts, right? We're gonna see that in practice as well. This is being powered by Mesh and Midnight SDKs with UI components fully imported and ready to customize. So in the SDKs, you have two options. You can either import the UI, the wallet widget, or you can just use the components themselves. So in that way, if you just want to keep the UI as it is, it's okay. But if you want to tweak or change something, you're gonna have the code available to change whatever you want. Contract logic testing. This is important. We have these test frameworks. We haven't yet studied them on these sessions, but we're gonna go through this process. But in this template, it's already included. The contract logic testing, terminal-based UI, TUI for interactive testing. This is what we just finished on the last session. We went through the process of creating a transaction using a TUI. CLI for fast testing using the full Midnight APIs with providers. This is within the testing category as well, along with the contract logic testing. We haven't studied that yet. We're going to go through that process in the next sessions. React providers and hooks for seamless integrations. So how do you connect your codes with React to have it in the front end? So we're using providers and hooks to make it composable with other contracts and easy to understand and maintain. Fast builds and deployment with Turbo Repo. We are making everything automatic, right, and fast. The sleek UI and UX, we're going to take a look at the UI and the messages, what is user experience, and the latest Midnight libraries and compact tools. So this is up to date regarding libraries, and we are using the compact tooling that we just studied before, right? We were taking a look at the blog and start building. So we have this repo that is the one that we've been studying before in the main session. So let's go to the code and see how it's structured and how we started. So we have here the code, right? We have this Midnight the starter template. This is the same repository that we were using so far in the sessions. We just finished the first release, right? That integrates end-to-end a counter contract within a application with UI. So let's take a look here. Summarizing what we have already studied, right? What is the prerequisites to run this code? You need to have Node, you need to have Docker, Git LFS, and Compact. Right now, it's not mandatory to have LFS. Nevertheless, I'm kind of integrating that already within the starter template, because in the future, we're going to need to have that. And Git LFS, it's pretty much for large files. Whenever you include a file here on your repo and you upload it to GitHub, if that file, it's the size of that file, it's more than 100 megabytes, GitHub is not going to allow you to upload it, right? It's too heavy. So you're going to need to use a service of GitHub that is called LFS, that pretty much is going to attach a link, and then the file itself is going to be stored on the service, LFS. So we're using that already to store some specific files. And then we have the Compact that it's going to be installed using the latest Compact developing tool. The setup process. So LFS, it's a binary that you have to download. Here is the commands that you have to run. So you just copy here in your CLI sudo dnf install git lfs and git lfs install. And then for the compact tools, now it's really easy to install. You just run this command here that we saw on the blog, curl, and you just download this binary, and automatically you're gonna have available this command compact. So for example, here let's test. I have already run this command, right? Once you run it, you download it, you're gonna be able to run this compact, for example, check. See, in my case, I have a compact installed on my computer or version 0.24. For example, compact update is going to install the latest compiler. So in this case, since I already have compact installed 24, if I run this compact update, it's going to see that I already have the compiler, so it's not going to do anything, right? I already have it. But if you, in case you don't have any compiler installed on computer, by running this command, compact update, is going to check, okay, you don't have the compiler on your machine, I'm going to download it for you, and I'm going to have it install and make it ready for you to use it in your code. So you just run compact update, and then you just go through this documentation to download Node.js and Docker, right? We have Docker here now installed. We are using Docker desktop. So to confirm that you have everything okay, just run these commands to make sure that everything is installed. For example, Node version I have installed, npm version I have installed, Docker version I have installed. In the case for LFS, we run git LFS version, and we have the version of LFS. And the compact check, we just ran it before, right? I'm gonna run it again. Compact check. So you can see here that we have the latest version 0.24. Perfect. We have everything that we need to start testing the code. So for those ones that they don't have this code still in the computer, you just have to go to Mesh organization and look for this repository, midnight.meshjs.dev template. You just copy the link and then just do git clone and paste that link, and you're gonna have this code. So the structure of this repository, it's divided in 3 folders. We have already taken a look at the counter contract folder and the counter CLI folder. This front-end Vite React, it's where the UI part is implemented. We're gonna keep studying it in details, but the purpose of this session right now is just going through the whole architecture, just for you guys to understand how all this works. So network configuration. This is you can run your contract using the testnet network, or you can run it on the undeployed network. Now, to test this and run it, we are gonna first test with testnet and then with undeployed. Okay, so for testnet, we have already the infra that we need. Also, we need to make sure that we have lace beta, right? For those ones that they not sure if I mentioned that on previous sessions, but well, I'm mentioning it right now. Before we had to download some Midnight wallet specifically for lace, but now on the official wallet for Midnight and lace is this lace beta. You can download it as any extension. You can download it, and then you're gonna have this wallet here. See? So you're gonna have this wallet, and here on settings, you're gonna be able to choose different networks. You have the testnet and you have the undeployed. Right now, we're gonna use testnet, right? So we have testnet, and we have 793 tdust. In case you don't have any dust available, the only way for you to get dust is requesting somebody else to send you dust, right? We can send dust to another address, or you can request it through the faucet. Okay, so you have tested, you have fonts. Perfect. So now you have to open this file here, front-end vid react source app, and ensure that the network ID is on testnet, because your application can run on testnet and undeployed. And how do you choose that on the UI? Is by changing this testnet point of the network. So let's go to front-end vid source. We have this app tsx, and here we have the set network ID, and here we choose what is a network that we want to run our UI. So right now it's on testnet, but you see here that you have different options. You have devnet, that is not supported anymore. We have mainnet, testnet, and undeployed, right? So yeah, mainnet is not available yet, right? So we only have this testnet and undeployed. In this case, we're gonna test first with testnet, so we choose testnet. Okay, let's keep reading the documentation. Okay, I have the network ID testnet, it's set, perfect. Now configure the contract address. In the same file, locate the contract address constant and replace it with a counter testnet network contract address. So here is the contract address of the counter type kind of smart contract, and you can use it here to use your specific contract based on the counter contract, right? In case you don't have one, you can use this default to test, but I'm gonna show you how you actually deploy a new contract and you can update this address in case you want to use your own deployed counter smart contract. But for now, let's start with this default one that I have already created. And since it's testnet, you can use it because it's deployed on the network, on the testnet network. So we're just gonna keep it as default. Perfect. What else? So now we have this contract address set, and now we just have to build and start the development. So to build, first you have to install dependencies. For that, you just run npm install and you run it, and then you build it, npm run build. All these have to be run at the root directory, right? You don't have to enter any file, you just run it at the root level. So npm run build. After that, you build your repo, and then for run the application itself, you just run the start app testnet command. So we're gonna run it. What this command is actually gonna do is gonna spin up a proof server, and it's gonna create an instance of our UI. So let's run this. So you can see here that on the Docker, we have this proof server that was spun up. We can see here the logs, right? We can see here everything about the proof server, and our application now it's running on the port localhost port 5173. So if we go to that port, we can see here that our application is running. So we have the home page where we can see what are the features available right now on this starter template. We have a wallet widget and we have a counter contract. Wallet widget, we have this nice UI, and then we can interact with the contract. Right now it's connected, I can disconnect. If I connect, there is a pop-up that shows what are the wallets available. Right now, the only one is Lace. In the future, it's gonna come more. So for example, I want to connect with Lace, and I can see here that my address ends with testnet. So I'm connected in testnet. And then here we have some wallet actions. In case you don't want to interact with the widget itself, you can, for example, disconnect. You can connect. You can open a wallet without having to click here, right? Here, you can just click here, for example. And you have the dark and light mode, right? Really nice. And regarding the counter, we can see here that we already we have to connect our wallet before interacting with the counter. We have to connect, and once we are connected, there is this loading. That means that we are loading the smart contract. Once that loading disappears, means you have already uploaded that contract, and by that contract I mean this one here that you put here in this contract address. If that contract doesn't exist, it's just gonna keep uploading. But if you don't have any, don't worry, you can still interact with this contract, with this loading, being loading something, the contract, the address. You can still deploy a contract, and then the address of that deployment, you can use it, you can copy and paste it on that location for the UI actually display the different options for that smart contract. So right now here we can see that we have the contract value, the private data, the terms. We're going to see that some status controls of what's going on in the platform, and the contract address. And we're using this address, that's the default one, and the counter it's already in 5, right? As more people interact with this contract, whenever you increment the counter, this value is going to increase. So I hope everybody to interact with this, and let's see if this 5 goes to 6, 7, etc. And if you want to create your own contract, you just have to deploy one. And for example, we're going to deploy one contract, says here, signing the transaction with midnight.meshjs wallet. We're going to sign it. And we have here at the bottom really nice flow messages that says what's going on, right? We have signing the transaction with midnight.meshjs wallet, submitting the transaction, waiting for the transaction finalization blockchain. So we have a really nice user experience. The user knows what's going on while waiting for this transaction to take place. So waiting for transaction. So now we just have to wait, right, for the validation, the updating of the indexer, and the UI receiving that information. Perfect. We deploy a new smart contract. This is the deploy contract. In case you want to use this deploy contract, you have to copy that, and you go to your code and you just paste it here. And in that way, you're gonna have this new contract display here. Let's test that. We're gonna paste it here, right? And now if we go back to our code, you can see that it's loading this new contract. And perfect, we have a new contract that now the counter is 0. It's a new one. If we increment, this value is gonna go to 1. Perfect. So this is testnet. Let's now configure our application for undeployed. For undeployed, we have to, first, we're gonna close these instances here, right? We don't need them anymore, right? Perfect. And then we have to configure your own wallet address. So go to the counter CLI. So now we have to go to this other file, counter CLI. Counter CLI, source, scripts, prepare standalone. So we have this CLI part that what it's actually gonna do, it's spin up your instances for the node, indexer, and the proof server, right? Because now you're gonna need those 3 instances, and you're gonna send funds to your own wallet, right? This is the way it works in standalone. That's something that was discussed on previous sessions. So how do I get that address that I have to put here, my own wallet? So first you have to go to your Lace wallet and change it to undeployed. You choose undeployed, save, and then you have the undeployed, right? Right now it's syncing because you don't have the instances up yet, but you can still see what are the what is your token. You can see your address. So you can see here that you have the undeployed network now, and this is your receiving address. You just copy this and you just paste it. And you just paste it here, right? In my case, this is my undeployed local address. So what this script is gonna do is just spin up those instances and send funds to this address. So in that way, you're gonna have funds on that wallet. Perfect. So what else? Then replace with your own undeployed network wallet address. Okay, we did that. Then set network ID. Open front end, the app, and change it to undeployed. So perfect. Now this app, source app. Now instead of testnet, it has to be undeployed, right? For this contract address, in this case, we don't have any, because undeployed, the way it works, you create a fresh network. So there is nothing deployed. So you just have to first spin up the networks, deploy a contract, copy that contract that you just deployed, and paste it here. So we're gonna do that. So we have updated the undeployed, and now you go through the same process. If you already did this, you don't have to do it again. npm install, npm run build. But for running the applications and the instances, you run this command now. And you have two commands. One for your instances that you have to, you don't have to close it. They're gonna keep running while you're interacting with your application. And then this one is for the app itself. This is the instances and this is the app. So we have these two CLIs in the first command line terminals. I'm sorry. So in this first one, we're gonna run this command, instances. So with this command, our instances are gonna spin up. So we see here, now we have these test containers and we have these three instances: proof server, node, and indexer. Perfect. And they are running here. And on this other terminal, we are gonna run our application. So we copy this and we run our application. So it's on 5173 again. So we're gonna just refresh this. It's refreshing. We go to the wallet UI and we are gonna disconnect and we're gonna connect again. And we see now that our address is undeployed. So we are connected on the undeployed network. And if we go to the Lace wallet, we see that our wallet is synced because we have now the instances running. Excellent. So now, regarding the counter, we're gonna see that this loading keeps loaded because that address that the contract is, the application is looking for doesn't exist on the network. So what we have to do first is to deploy our own smart contract in our network. So we're gonna deploy a contract. You see here, sign in the transaction, sign transaction. I'm gonna sign in. Confirm. And here we see signing the transaction with Midnight Lace wallet. So it's gonna go through the process. It's gonna keep giving us these messages. So we have a really nice user experience. The user all the time knows what's going on during this transaction. So it's waiting the transaction finalization on blockchain. Perfect. The contract was deployed. So we just copy this address and we paste it on the application. We paste it. And then see, this loading disappeared. And now we have uploaded the contract correctly. We have this contract. So what we can do now is increment. Let's increment, for example. So we increment counter. We see here incrementing the counter. We sign the transaction. We're gonna sign it. Confirm. It's gonna go through the process, and then here in turns we have some comments regarding the transaction of the circuit specifically. In this case, we see that we are incrementing the counter, and it's going. And this is the status of the transaction itself. If you want to see on the Docker, you can go through this logging as well on Docker and see we have now incremented successfully the value of the counter. It appears as one. So perfect. We have gone through the process, how to interact with the standalone network, the tested network, and we have this really nice framework. What is nice about this and the idea behind the starter template is that if you see here the codes, the way it's structured is that you have these folders of contra CLI, contra contract. As you keep adding new contracts, you're gonna have here, for example, bulletin contract, token contract, DeFi contract. You can have as many contracts as you want. The contra CLI purpose is for testing, and the front end, at the end, what's going on? Here on the app, you can see that we are using these providers. So we have this Midnight Mesh provider. This is for the wallet. You have the counter app provider. This is for the counter app. As you keep adding new contracts here, what's gonna happen? You're gonna just keep adding new providers, and then for each provider and each contract, you have this specific file here on modules and Midnight. So here you have the counter UI and counter and the wallet widget. Again, as more contracts keeps adding on your application, you're just gonna keep adding these new providers and hooks. For example, we have the counter UI. In this counter UI, you specify here the API, the context, and the hooks. Everything within that folder. So if you just want to copy whatever contract a developer is using and you want to add it on your application, the only thing you need to do is just copy this file and paste it on your application, and everything's gonna work, and just keep adding these providers. So this is kind of interoperability at the application level, so everybody can follow the same steps, based the same frameworks, and keep adding new features. It's really easy as copy and pasting into your application. So for example, in this wallet widget, control UI, we have context, and this context is what is this provider here. The result of this context is this counter app provider. And then you have hooks. So if you go to the application, you don't need to worry about the implementation about this. This has already been implemented, and you just want to use the features of that contract. And by features, I mean hooks, right? You want to use these hooks. So for example, let's take a look at a page. For example, here in the application, we have this counter UI with these different features and actions, increment, how this looks in code. For example, we go to pages, we go to counter, and this is the indexer. So this is a code, nothing else. This is pretty much UI, and regarding commands, you have this. For example, for deploying a new contract, you just have to run the function on deploy. That's it. You don't have to worry about anything else. You just run a function that it's a hook. And by hook, what I mean? Where is this function coming from? If you see here, we're using this hook provided by the library coming from the modules, and you just can grab some features already implemented. In this case, we have this on deploy function, and just deploy your application. For running the circuit, we have this API. So we just run whatever circuits we have available. Right now in the counter contract, we only have the option to increment. But imagine that we have a contract with 10 circuits. You just call this API using this hook, really easy. And then you just can call whatever circuit you want, right? In this case, we have increment. But in future contract, we can have here like 10 options. So at the end, we can divide people that actually do the smart contracts, people that do the integration with React, and people that are actually writing the application itself. So yeah, that's the idea of this template, and I'm really happy that a lot of developers got in contact, and they're gonna start following this procedure. At the end, the main purpose and objective of this is creating interoperability and everybody adding features on top and collaborating. Okay, so that was a lot of topics discussed in this session. And well, I'm just gonna see if we have any questions here in the chat, or if anybody wants to jump into the stage. And let's see, here we have Honorat. I must disconnect and rewatch it on YouTube later. Thanks for your work. Thank you, Honorat. And not sure if anybody wants to jump into the stage or have any questions. Otherwise, we want to call it for today. For next session, what we are going to keep doing is going through the details of each of these topics, right? We talk a lot about things, right? But on the Twitter that I just mentioned, we talk about the test frameworks. So within here in the contract, we have these test frameworks. We're going to study that. On the CLI, we have also this test framework. We're going to have to go through that. And then we're going to have to go through the front end itself and understand how everything works, right? In this midnight session, we're going through all the topics, but at the end, you can decide which part you actually want to implement, right? And yeah. Islands mentioned, the island just went live. Let's go. Yeah, Island. Just when we were discussing the here we were discussing the some topics regarding the Glacier Drop, some limitations, what's going on, and we actually went through the process. So yeah, I'm gonna do it, and I'm really happy that a lot of people are interacting with this Glacier Drop site. So yeah, let's go, and really happy with the results and how the night it's being airdropped to everybody in the ecosystem. Okay, so that's it for this session. See you all next week. See ya. Bye bye.